It's been about 2 months since I installed the WOLFBOX powered tonneau cover onto the bed of my Ford F-150 Lightning. We replaced a Retrax Pro XR tonneau cover, which leaked when it rained a lot, with this, and so far this has been waterproof, weatherproof, and really reliable. I also like the fact that you can have pretty rainbow effect RGB lights when you open it up. And so far, everyone on the team has enjoyed it too. It's smooth, it's quiet. In fact, it's a lot quieter than the previous tonneau cover was. But there is one thing that it's missing, and that's the ability to tie it in with any kind of in-cab control system. In fact, if you want to use these buttons here, you either have to have the keys with you, and who carries keys these days, or you have to have a smartphone app. Now, WOLFBOX makes a smartphone app. You can download it from the App Store of your choice, whether that's for Android Auto or Apple iPhone, and you connect it to your phone using Bluetooth Low Energy. So far, so good. But unlike the Phone as a Key app that works with my Lightning, you actually have to bring the app to the front and wait for it to connect before you can use the tonneau cover's buttons right here. So I figured, wouldn't there be a way to get this to do that without having to carry these around? Turns out there is, and I've built it.
Speak friend and enter. What's the Elvish word for friend?
Mellon.
My dad used to joke that when I was very young, I spent most of my time trying to get things to do something that they weren't inherently designed to do. It didn't matter if it was a bicycle or a piece of electronics. He said I was always trying to add new features. And that's exactly what I've done with this tonneau cover. Inside this 3D printed enclosure is a little ESP32 motherboard. It's basically a little microcontroller, and I can use this to connect to Bluetooth, to Wi-Fi, and it will run any code that I happen to write that will fit on the memory and is compatible with the processor. And this little device here is often found in people's smart homes. If you run Home Assistant, the chances are you've either got one of these or a similar model, and you've played with it to add new features or to tweak your smart home. And shortly after I got this tonneau cover installed, and I realized that it uses BLE, that's Bluetooth Low Energy, to communicate between your smartphone and this device, well, I realized that maybe I could get this to talk to that. Now, I happen to have both an Android phone and an Apple iPhone. Regulars to the channel will know that we use Apple products in our studio. That goes back to the fact that I learnt Apple computers when I was at high school in the late 1990s. No other reason, and I've just never migrated away. But for a while, I ran an Android OnePlus One, and after I replaced it with an Apple iPhone, I kept that unit around because it was really useful for reverse engineering. And so, with a rooted OnePlus One and a device in developer mode that allowed me to capture the Bluetooth handshake between my phone and the tonneau cover, I was able to reverse engineer what this needs to allow me to press these buttons. Now, right now, you'll notice nothing is happening because my keys are way over there, out of range of the tonneau cover, and this isn't plugged in. But if you give me a moment, I'll go turn the truck on. The reason I have to turn the truck on is because the little device that I just showed you needs USB-C power to operate. We'll give it a few seconds, and then if I hit this button, it will operate as if I have a phone connected or as if I have my remote control connected. And if you don't believe me, I'm gonna open the door here so you can see. Let me show you one more time. But if I now go into the truck and I unplug that little 3D printed ESP32 enclosure, now it's disconnected. Nothing happens. And so I thought, what if I could design and build something that sat inside my truck that was more secure than this? Because this is not secure. This is not safe for me to use. And no, it's not in my truck normally. And certainly if it is, it's not plugged in. But what if I could develop a piece of hardware that was plug and play for anyone who has this tonneau cover and a Ford F-150, either a Lightning or an ICE version, and it just allowed you to automatically enable and disable when these buttons work based on whether the vehicle's being driven or whether it's locked or whether it's unlocked. And moreover, bring back a piece of functionality that I really loved from my previous tonneau cover. That is the ability to use the HomeLink visor to send commands to my tonneau cover. And I've done it. And I'm about to show it to you. But for that, let's go inside. I've explained the issue that I'm trying to solve. I've shown you a proof of concept. Now comes the tough part. Building a circuit that does all of the things that my proof of concept does, but also adds an extra layer of security to make sure that my tonneau cover doesn't just automatically open and close when the truck has power to the particular circuit that I'm building. To make it secure, I'm going to have to jump onto the CAN bus and read CAN bus signals from my truck to interpret the state of the truck's door locks, to figure out whether the truck is open, whether it's closed, whether the doors are locked, whether they're unlocked, whether I'm driving, whether I'm in park. And I've built this truth table to determine the different modes of operation that I want the tonneau cover to have based on all of those states. Remember, my end goal here is to give myself the ability to use phone as a key, which is my preferred and default way of driving my truck, to unlock my truck just by walking up to it, but then for the tonneau cover to also automatically operate as soon as my truck realizes someone has legitimate access to the vehicle. And I also want that to work if I use the keypad on the outside of the truck. So maybe my phone has run out of battery and I still need to gain access to the truck. I want to be able to just enter my keypad code on the door and then have all the doors unlock and the tonneau cover's buttons on the rear of the tonneau cover to automatically also operate. But I also need to make sure that the tonneau cover locks itself as soon as there's no presence of a key or the vehicle has been relocked. Because the last thing you want is to get out of your vehicle, lock it, walk away, and have a period of time where the tonneau cover will still open to anybody walking past. I also want to make sure that when the truck is in drive and we're stopped at a set of traffic lights, it's not possible to just randomly press the buttons on the exterior of the truck, on the tonneau cover, and have it suddenly open and close, because that's a security risk too. And so instead of just having an ESP32 module, one of these little modules here, which is basically what my proof of concept was built on, I decided to design an entire circuit. That's here. The schematic for it. So we've got a circuit here. This handles the power. Then we've got the the radio transmitter. I'll come to that in a minute. Well, actually not. It's not a transmitter, it's a receiver. And that's a very important part. I'll talk about that later. Then we've got the CAN bus section, which reads what's going on the CAN bus and then makes sure that the Mellon system knows exactly what's going to happen and when. And then finally, we've got the processor itself. And I had never used KiCad really in anger before. And this is the first time. Now, learning how to do this took a little bit of trial and error. I have been tinkering with electronics for years, but this is the first time I've ever tried to design my own printed circuit board. That then led me to develop the actual board itself. And the board itself looks like this. Now, if you've been following us on social media, maybe you watch the YouTube channel and you go to our community posts, you have probably seen this board a couple of times. I've actually posted images of it, but you've never actually seen one in the flesh until now. Behold, my very first printed circuit board that I designed myself and had produced for me by today's video sponsor, PCBWay. Now, PCBWay have never worked with me officially before, but if you've watched the video that I made on the OVMS system for my Chevrolet Bolt EV, you'll know that I ordered some of these boards from PCBWay that somebody else had designed, and then I did my own soldering of components on this board, and it was the first time that I'd ever made populated a PCB from scratch. So I decided to make my own and give it a go, and PCBWay were very happy to work with me on this. PCBWay are a fantastic fabrication fulfillment company. They make everything from printed circuit boards through to metal products, through to large format 3D prints. The list goes on. And not only do PCBWay allow you to have your own printed circuit boards produced professionally using a whole different wide range of options. You get to pick the color of your board, the thickness, the material. You get to decide how many layers your board is, which is very useful because some boards are really complicated. Boards like this is just a 2-layer board. I didn't need more layers than that. You get to choose what color you want the silk screen, the pretty writing and all of the text on it. You upload your Gerber files from a program like KiCad or KiCad, and then PCBWay checks it over, makes sure that the board is manufacturable. If they have any questions, they reach out and ask you. If you haven't specified certain things that need to be specified, they actually check that before manufacturing it. And then literally, it's about a week from the point that you get an email saying we're going to manufacture your board through to you getting an email going, yeah, it's on the way. And it arrives a few days later. Now, PCBWay kindly sponsored this particular board, so I sent in the design. They looked at it, they made sure it was okay, and then they sent me these boards. I got them through the mail literally a week ago, and today I have successfully completed populating the board with all of the components that I had picked from my original schematic. And today is all about testing that board and making sure that it works. So we've got our switches here. We've got an RGB LED here. This is the main power in and the CAN signal. This is a spare switch that doesn't have anything assigned to it right now, but may do at some point in the future. This little chappy here is ESP32C6, which is basically a little microprocessor that has a castellated edge on it, which allows me to literally solder this board onto the main PCB without having any issues. We've got our power stage up here with a nice chunky inductor and a big capacitor. We've got our power little tiny chip here that takes the 12-volt power from the truck and converts it to 5 volts, which is what this needs to have in order to operate. And then all of these components are basically either split between the HomeLink receiver, which is this big thing here. That's the antenna for the HomeLink receiver. The CAN bus, which is this little chappy here. And it allows this microprocessor here to listen for HomeLink remote control button presses, which is what this is. This is a HomeLink remote control button. It allows me to listen for a specific key code, which is very important if I want the HomeLink buttons that are inside my truck to operate. That's why that exists and that's why it's there. And then the CAN bus, which is right here, listens for the messages on the truck's CAN bus. Now, if you've watched the video that I did when I installed the WOLFBOX powered side steps, you'll know that I already produced a custom, I suppose it was like a custom addition to my truck's loom that allowed me to just plug in a separate little bit of loom that I'd built a CAN takeoff on, so I don't have to modify the entire truck's wiring system or make any permanent changes. And the same thing is true for this. So what I am going to have to do, unfortunately, is I will need to go back and remake that custom loom, because now I need to take extra things off. I need to take a 12-volt power supply off. I need to take the CAN off again. So I have two separate things looking on the CAN bus. And I also need to take a ground out. So I will need to remake that loom before I put it in the truck. But luckily I have some spare components just off camera. So that is going to be a future me problem. But what makes this board really fun was that because PCBWay was so great and they sent it to me in a very, very quick period of time, and they actually check it before they produce it, it means that if there were any errors on the board, like maybe I didn't properly ground it, or maybe I connected two separate nets that shouldn't have been connected, PCBWay would have picked that up and told me. So after about 6 hours of soldering, and to be frank, the soldering took 6 hours because I was going through my list of parts and double checking and triple checking. I have a board, and then I also have a custom piece of code which I can upload to this device. So when I put it in like so, it will power on, it will cycle through the test colors on the board, and I can actually connect a serial terminal. Hopefully what you're seeing right now on the screen is a serial terminal screen recording showing this unit running through all of its test routines. So right now the code that I have written with help from an LLM is not actually on this device. This is just the test code to check that all of the components actually work as it should, and none of the components are incorrectly soldered, or maybe I have bridged some wires that I shouldn't have done. So the test program works, the hardware test is complete, and now I have one thing left to test on this board, and that is that the 12-volt power works. So this works using USB-C power. So when I plug in the USB-C socket here, it will cause all of the LEDs to light up because this is providing power to all of the circuits. But obviously I can't have a USB socket plugged in my truck. So what I need to now do is check that this big boy here, this big inductor and this capacitor and all of these power circuits actually work. Now I've installed a fuse, the fuse is down here. I've got a diode here to make sure that if I accidentally wire it up wrong, it doesn't blow anything up. But now I've got a bench supply over here, one of my old bench supplies, and I'm going to plug in this board to this bench supply, and you're going to see if it works. I don't know if it will work. Let's find out. So I want to just make sure that I'm actually wiring it up properly. So for this particular test, I've obviously just got some jump cables here. So I want to make sure that the right one goes to the right one. So ground is going to be pin 1. So that one goes to green, and then power is going to pin number 2. So if I turn on the power now, this board should come alive. Fingers crossed. There you go. And this is the self-test that it goes through right now. It won't do this when it's completed, but it will go through this self-test procedure. Now, I also have to do a whole load of other things to this, right? So I'm halfway through designing the software, and the idea is that you'll be able to take your phone, go to your truck, install this, turn on the truck, and a Wi-Fi access point will appear on your mobile phone. You'll be able to configure it, so you'll be able to pair it with your Tonneau cover, because every Tonneau cover is going to have a different Bluetooth pairing code, and this will take care of that. Then you'll need to be able to train the remotes, so you'll need to be able to put this unit in a training mode when you press the sun visor. It will then basically do what your visor does, which is copy the HomeLink assignments that you want to use. That then allows this unit to listen for when you press the buttons, and it will then translate that into Bluetooth commands for the Tonneau cover. My previous Tonneau cover, the one that I had prior to the WOLFBOX, used HomeLink commands. So that's all it did. So this remote here is a HomeLink remote, and literally you press the open button and it opens it, you press the close button and it closes it, and you press the light button and the lights come on. And I trained my sun visor in my truck to mimic these buttons. This unit not only needs to understand those button presses, but it needs to translate it into the Bluetooth low energy commands that the new WOLFBOX Tonneau cover speaks, because that's what the Tonneau cover app speaks. Now, I decided to call this Mellon. Lord of the Rings fans might recognize it. It's from the Fellowship of the Ring. Mellon is the word spoken to gain access to the doors of Durin. And I felt that that was a really cool name, because you say Mellon and then the doors will open. Say, speak friend and enter. And literally that's what I want this to be able to do. I want this to know, oh, you're a friend. I will open the Tonneau cover for you at your command. But if you're not a friend, it's not going to happen. Anyway, I think I've just proved that the board has worked. I'm super stoked about it. I know that this is very different to a normal Transport Evolved video, but if you have any requests for this board, things you'd like me to try and get it to do, let me know. I'm actually going to be basing some of the code off other open source projects that are already existing. So a very similar unit using off-the-shelf components as opposed to this custom board. And what they've done is set up an automatic light that comes on their F-150 toolbox, just the gas F-150. So if you tell the truck to turn on the lights in the load bay area, it will also turn on the lights for the toolbox. I'm going to leverage that code in this build so that if I turn on the zone lights in the rear of my truck, or I turn on the bed lights, this board will notice that that's happening on the CAN bus, and then it will send a command again to the WOLFBOX Tonneau cover to automatically illuminate its lights. Now, as I say, I've still got to finish the app. I also need to design a case for this. I also need to test it. But I'd love to know if this is something, if it were available, would you buy one? I know it's a very niche market, but the fact that I've got this far tells me that I can, in fact, make it. And I'm really super excited about this. There are links in the down below if you want to actually go and buy a WOLFBOX Tonneau cover for yourself. Despite my criticism of how those buttons work, I still think it's an excellent Tonneau cover. Watch the full review if you haven't. Also go watch the review of the side steps. I'm very impressed with WOLFBOX's build quality, the way their products are designed. I have installed the side steps, as many of you know, in an unorthodox way that works really well for the F-150 Lightning. And me building this and designing this was more to enhance the ownership experience rather than, you know, to do anything else. I've learned so much about reverse engineering hardware. I've learned so much about soldering. This little chappy here, this is the receiver for this antenna. It's the receiver chip. This is the smallest integrated circuit that I've ever soldered onto a piece of hardware, and it is tiny, and I drag soldered the whole thing, so I don't have a heat plate. I didn't use solder paste to assemble it. If I actually think about making these in any volume, I probably will upgrade and use solder paste, because then I'll be able to solder it in literally minutes rather than hours. But if I were to sell this, there's a couple of things I need to do. I'd need to go through and get proper approval, because this has got a coil in it and therefore it can be a receiver. And there are certain things that would need to happen for me to be able to sell that legally. But the other option is for me to just make the design available free of charge on GitHub. If anyone wants to build it themselves, they're on their own and they have to do their own due diligence. Anyway, thanks to PCBWay for helping us out with this. If you have a PCB design, if you have a piece of metal work that you need to be made, if you have some large format 3D printing that you need, they are your folks. Go check them out in the link below. Tell them that I sent you. Also, thanks to the amazing long list of people scrolling by on either side right now. They are the reason that we are still here. This year, 2026 has been a particularly nasty year for the team here at TE for various reasons, and as many of you know, back at the start of the summer, my wife Kate lost her job. She was working for a large firm that just went through corporate restructuring, and they laid off a huge number of staff, and she was among those laid off. And without your support, we wouldn't be able to do what we are doing today. Now, Kate has been busy working on other things. She's been interviewing for positions, but she's also been working on a new piece of software that if you are a YouTuber, you're going to want to know about. But I don't want to say any more at this point because it's very early stages. I am the first test customer, and then we need to go through a public beta, and then cool things will happen, but let's not get carried away. But if you want to help us bridge the gap between that happening and where we are right now, your support would be very much appreciated. You can follow the links below. You can see us on Patreon. You can also send us money on Ko-fi. You can send us an old-fashioned check if you so wish, or if you want to sign up on YouTube, you can do that too. You can also go to our swag store and buy one of our cool t-shirts. This is not one of our cool t-shirts. I wish it was, but there's plenty of really cool designs. And Erin has been busy working on some new designs for this autumn. So keep your eyes peeled. Thank you for watching. Thank you for being the positive change we need to see in the world. And until next time, keep evolving.